right, good morning. Good morning. Good morning, students. It is week 13, and we are about to enter our last unit together. This is so exciting. I have to show you. Coyote is super excited. And also just took a shower last night with her. She got a little bath. Look how clean she is. Oh, yes. Okay, so enough about my dog and more about the lessons this week. Mission Beyond. I'm pretty excited about this unit. I think it's going to be a really cool way to wrap up our course together. Although I am a little sad that I've really grown to love our little community here, especially getting to meet everybody on Fridays and talk to you individually on the phone. So yeah, we'll have to stay in touch. That'll be cool. But until then, let's enjoy this lesson together. Yeah, let's just track to over here, course modules. You can take a look and see that this week we have 2 lessons due, Making the Dream Team and Unseen Danger Radiation. So when you go into your Learn space, that's going to start here. And seems like sequentially we'll have to go through the headquarters first. This was actually from last week, so we'll do that together too. But we're completing this headquarters unit this week. And I want to bring up the really cool way that you can engage if you are honors. We'll do this as a discussion. But the question is, how can you use your own body as an experiment? Which sounds maybe a little bit scary, but observe here as we track through this mission, we'll go through the skeletal lab, the muscular lab, the cardiovascular lab, and the nutrition lab. And through each one of these discussions, we'll be able to gain more information about biology through our own bodies, which is the most experiential way that you can learn this material. And so I will make a wonderment for this. What experiment do you want to run in your body? For example, I coach track and field, and I have a student who is feeling really tired all the time. And so we're working together to see what one thing, right, to be a controlled experiment, you want to change one thing at a time. What one thing can she change in order to measure the result and to see if that has an effect on her energy levels? All right, so let us begin. Begin, ASUPD, getting started. Welcome to the Infinity Space Center. Mission briefing. You have officially reached the last leg of your BioBeyond journey. You should congratulate yourself for all the work you've done to get to this point. You are now ready to launch into space, SPAC, for search for life beyond our planet. To do this, you'll have to ask yourself where to start. Here in the Infinity Space Center, we've determined that the best bet to search for life beyond our blue planet is on Mars, the red planet. In this experience, you'll take the role of mission commander, both planning the trip and launching a crew to the surface of the red planet. Sounds daunting, don't worry. Each lesson in this unit will teach you a little bit about what you'll need to know to tackle this challenge. That's good. I already feel like I live on the red planet out here in Moab with all the red rocks, so I feel quite at home in this mission. How many of you guys have really been fascinated by space travel? I'm curious. All right, a little bit of logistics. Lessons are located in rooms within the center. I have to warn you, the mission is not going to be easy. A journey to Mars and back will take no less than 2.5 years, and a lot can go wrong, both aboard the spaceship and inside your own body. As you imagine what it would take to get humans on Mars, you will visit the various rooms of the Space Center. In each room, you will learn more about how a journey to Mars can affect your crew and how you can confront these issues. Take a look at the rooms shown below as blue spheres. Okay, so we just looked at those. Those were the different labs that we're going to go into. Completing your training. You can explore rooms in any order you like. As you navigate between the rooms in the Space Center, you'll notice that each contains 1 to 3 lessons. Each should take about 30 minutes to complete. After you complete the introduction, you can explore any room you like. Some lessons require to be done in a certain order. If the lesson is locked, make sure to complete the ones that precede it in the room in order to unlock it. Although there is no particular order to visiting rooms, some have found this order to be particularly beneficial. So we'll track this anyway. Headquarters, skeletal nutrition, muscular cardio, launchpad. All right, cool. Where's my button at? Next. All right. Messages from Mission Control. You will get data from Mission Control to help you along the way. To give you more information about your mission, you will receive reports on the risks of spaceflight, or ROS reports from Mission Control. And I'm guessing ROS means risks of spaceflight, ROS. These reports will give you leads on how to best prepare your crew for the mission. So yeah, you're welcome. They're kind of snotty here. But anyway, this is what we'll look into. We'll have a bunch of different astronauts, which, this is my joke from this week. Why are they called astronauts? They're not like not against astroflight. I think they should be called astrophores because they're for space travel and exploring the astrosphere. But anyway. And this is going to alert you for any dangers your crew will face in trying to reach Mars. Can you think of what kind of dangers might we encounter? What does it take to go out into space? What are we not going to have up there that we really appreciate down here on Earth? Maybe take a deep breath. That's a pretty big one. At the end of each lesson, you will get the chance to apply what you've learned to develop your plan for a mission to Mars. For example, you may be prompted to make adjustments to the crew's diet and exercise plan, and think about which spacecraft will be best for your journey based on what you've learned in that lesson. To do this, you will use the My Mission app in the Beagle. To access this app, select the Beagle icon at the top right corner of the screen and then press My Mission. Okay, so I think that's up here. This is that, and then this is that. We're going to practice. And it says here, you can exit out. Open the My Mission app and insert the duration of the flight to Mars. It will take about 300 days. How long is that? It's a little bit less than a year, like about 10 months. Then you will close the app and press next. Okay, so here we go. Opening, My Mission, duration. That's already 300. They should have no naked numbers, so days. That's kind of important. 300 what? Distance. What makes Mars the best celestial destination for human spaceflight? We found a stream bed and a lake, clay that could have formed in salty water. Dark streaks lengthen and retract, indicating water. Any signs that show water suggest that life could have evolved. Life on Earth could have been succeeded by life on Earth. Life on Earth could have been seeded by life on Mars, like as in planted there from Mars. An asteroid ALH A84401 looks like fossilized bacteria and has chemicals that were formed from decaying microbes. So those are our evidence for reasons why we should go search for life on Mars, way 500 million miles away. Cool. Okay, at the end of each mission, we'll be prompted to open up our My Mission app, make changes to your plan, and then close your plan and press next to move forward. Cool. So every time we'll have to open up this My Mission. That's pretty cool. All right, let's practice using the My Mission app. Fill in some of the remaining sections of the mission summary screen. The distance of a mission to Mars can vary depending on the changing positions of the Earth relative to Mars, but it is approximately 800 million kilometers or 500 million miles. Fill in the distance to Mars in miles or kilometers. So open this up, My Mission. Mine's already filled out. I don't know if yours is, but that's cool. And press next. Okay, so what does make Mars a good place for search of life beyond Earth? We just kind of read this, so here we go. Let's watch this. So, that was a lot of information, but pretty exciting. It's also exciting just to note when you have a hypothesis that's put out by a scientist. I like that they said maybe not everybody agrees. So, this is a good chance for us to use critical thinking skills and be able to recognize what kind of evidence we're using to draw a conclusion. So, a lot of like news report stories nowadays want to be able to say, well, the science shows there's life on Mars. And it's like, wait a minute, what science? And let's look into that. So let's look into that. The Martian meteorite, like they said, ALH 84001, discovered in Antarctica, showed signs of microbial digestion and decay. And so the signs there were actually worm-like fossils, and I think they did some chemical analysis of the actual molecules that would have been formed if microbes were chewing up food and spitting it out. This discovery is suggesting that there may have been life on Mars billions of years ago. However, many dispute this claim, citing the formation on the meteorite may have been formed due to physical processes alone. So just because you have an imprint that looks like a worm doesn't necessarily mean there was a worm on there. And I say worm like a microbe. According to the Mars Curiosity rover, 2% of the soil on Mars is made up of water. Though it is impure, it would be possible to make drinking water from this source. So this kind of brings us to The Martian. How many people have seen The Martian? I kind of want to go back and rewatch it or reread the book because he actually splits the fuel that he used in order to make water. So when they say it's bound up with other things, it's impure, that means the H2O is actually locked or bonded to other molecules as well, other elements. Okay, and here the last thing is the Mars Curiosity rover took pictures of land formations on Mars. Formations that show signs of water erosion, suggesting that there may have been liquid water on the planet. So again, suggesting, right? So let's go, I just want to show you this article because I love this picture too, how beautiful. But this is the picture they're talking about. So imagine these are the streaks, and you would say, oh, that looks like on Earth when you have what maybe is called alluvial fans, or you have material that gets pulled down off a mountain. You might say that looks like running water flowed to erode those. And also we found hydrated salts. So if something is a salt that is bonded to water. But then, and this is actually University of Arizona. Okay, U of A, not Arizona State University. I always get those mixed up, but anyway. Then there's this editor's note. The findings described in this press release were updated with additional research published November 20th, 2017, and described in Recurring Martian Streaks, sand, not water. So here we have another perspective, like could this have been falling sand and maybe not water? So I'll link this, you can read this whole. Oh, this is an animation, this is kind of cool. But we're going down a rabbit hole. I'll link this and we'll get back to our lesson here in a minute. Pretty cool. All right. Seems like there would be many reasons to take a trip to the Red Planet. Who knows what we might find there? With that in mind, let's finish this lesson. By the end of this unit, you will know the fundamentals of how your body operates, how its various systems are affected by spaceflight, and how you can use this knowledge to better understand your own health here on Earth. Now that you know your mission, your first step is to select your crew. Select your crew by visiting the Making the Dream Team lesson in headquarters after the lesson. What lesson should you take after this one? Oh my gosh, it looks like we should do Making the Dream Team. Let's do it. Okay, a brief aside as I was waiting for this to load and finishing the lesson. And I'll wrap up here and just make a new video for the next lesson. But I do want to take you down this rabbit hole if you want to go with me. So I read this article, and it so seems when you research it, these lines disappear at colder times and appear during warmer seasons. So you might draw the conclusion then that When it's warmer, the water is liquid and then it flows. And when it's colder, it's frozen and it doesn't. And so they're trying to follow the water. And here they didn't quite find water, but they found hydrated salts. And I was like, what is that exactly? And they go on to suggest that based on this new technology, or it's not new, but technology called spectrometry, a spectrometer, it basically shows a signature of particular chemicals as you shine light at your sample. So if it has certain chemicals in it, it's going to make it diffract differently, and then it's going to be able to be picked up in a signature way. Does that kind of make sense? It's pretty cool science, but okay. So they found something called perchlorates, and I'm like, I've heard of perchlorates before. So here, in the form of magnesium perchlorate, magnesium chlorate, and sodium perchlorate. Some perchlorates have been shown to keep liquids from freezing even when conditions are as cold as minus 94 degrees Fahrenheit. On Earth, naturally produced perchlorates are concentrated in deserts, and some types of perchlorates can be used as rocket propellant. And these perchlorates had previously been seen on Mars, and they found them in the 1970s Viking missions. And why are perchlorates interesting? Because they might be bound up water. So then I was thinking about perchlorates even further. Well, and I'll get to that in a second here because that's an interesting story as well. But I find it interesting here that for Oja, the person conducting this experiment, this investigation, he says the new findings are more proof that mysterious lines he saw first darkening Martian slopes 5 years ago are indeed present-day water. So notice the jump sometimes that people can make when they want to prove a point. And so again, we just have evidence to support what could be a possible hypothesis. I just think that's pretty important nowadays. And of course, the more we study and the more that we get evidence, we can form stronger and stronger conclusions. So go with me on this little rabbit hole here to the EPA. Remember, we talked about the EPA in the lesson with Rachel Carson, who wrote Silent Spring, and the EPA basically investigates stuff like, we've talked about this a lot, safe drinking water. And so this website, this whole page is talking about what are some of the dangers and where is it found. The danger of having perchlorate in your drinking water is that it disrupts your thyroid gland by inhibiting the transport of iodine. So I just thought this was a cool connection for you guys because you've worked with iodine. We do need iodine, right? We have iodized salt. If you look at what your salt's made of, has iodine in it. And the perchlorate actually blocks the transport, so think down to the cell membrane, by chemically competing with the iodine. So remember what our cell membrane looks like. It's mimicking the iodine so that it basically will block one of these transporters. And since they're bigger molecules, they have to go through. And this would be by means of passive transport, but once it gets blocked, there's a higher concentration on the inside, and it's no longer going to diffuse in. So we're not going to get enough iodine. So now, what's the effect of not having enough iodine? It can actually affect developing fetuses because your thyroid hormones rely on iodine in order to make those hormones. And so if you don't have the right hormones, you're going to have delayed development and decreased learning ability. So that's a pretty big reason why you should remove perchlorates. Then, of course, I go to this spot of like, all right, well, how much is too much? So here they have the concentration threshold. And then I want to know, how could you test your well? And you can actually you can go here and have someone test it. So an interesting investigation to go down, especially considering this is used in rocket fuel or different types of, and it's concentrated in the desert. So having us live in the desert, and I wonder, like, for example, Owen, you were wondering about the effects of atomic bomb testing out by where you live, maybe perchlorates could be something to look for. All right, we'll wrap this lesson up and I'll make the next lesson here. That was just this first one, headquarters and getting started. So we'll go on to the next one, making the dream team and unseen dangers. We'll see you there.